Okay, this is 1.3.2, looking at the Earth and different parts of crude oil and how it's made. Okay, so the first part of this is to draw and label the Earth. Really easy then, you've got your crust, mantle, outer core, inner core. Describe continental drifts. So in 1912, Alfred Wegener suggested that continents were once joined together in a supercontinent called Pangaea. Over millions of years, they drifted apart. His evidence then was the fact that all the continents look like they fit together like a jigsaw. You've got similar rocks on different continents, similar plants and animal found on opposite sides of the ocean. How do the tectonic plates actually move? It's convection current. So a big thing with Wegener is that people didn't believe him. Eventually we came up with tectonic plates and convection currents to prove how it worked. Okay, you need to be able to explain what the early atmosphere looked like. Okay, it was lots of volcanoes, okay, constantly erupting, loads of ash cloud, and it was 95% carbon dioxide. Okay, big things that have caused the carbon dioxide levels to decrease is photosynthesis. Plants take in carbon dioxide and release oxygen, so it causes the levels of carbon dioxide to decrease. Okay, today it's about 78% nitrogen, 21% oxygen, and then there are a couple of other gases like carbon dioxide and argon. Tectonic plates then, conservative, the ones that go over each other, rub together, cause friction. This is where earthquakes are. Destructive then, they go together. The less dense plate goes above, so the more dense plate goes underneath and gets into the magma. This is where mountains happen. And then constructive move apart, so it's where new land form because the magma rises in the middle. So groups are the ones going down, periods going across. They're arranged with similar elements that are grouped together. Big thing to remember is that in period 1 there's only 2 of them. So big thing to remember about period 1. Kind of a brief overview then of group 1 and group 7. Don't spend a lot of time thinking about it. Group 1 then, they've all got 1 in their outer shell. Properties: conduct electricity, heat. They're shiny when and they're quite metallic when cut. They've got soft, they're low density, they've got low melting and boiling points. So chlorine then, fluorine, they're halogens, they're in group 7 in their outer shell. Poor conductors, low melting and boiling points, low density, diatomic molecules. Then, looking at how crude oil is made, this is really important. You need to remember these 3 steps. So, dead marine plants and animals, intense heat and pressure, millions of years. How do we separate crude oil? By fractional distillation. What is cracking? Long chain hydrocarbons into smaller, more useful hydrocarbons. What is polymerization? Removing double bonds on a monomer to attach long chain polymers to make plastics. What are the problems with recycling plastics? They're toxic when burnt, non-biodegradable, and they fill up landfills because they don't biodegrade quickly. What is a bioplastic? Plastics made from using vegetable oil. This then is the second part of 1.3.2, looking at other parts of kind of extracting elements from our Earth. So, where are metals found? They're found in the Earth's crust in ores, and here is loads of different ways that we can extract them. So if they're crude oil, something we can drill for them. If they're oxygen or nitrogen, we fractional distillation the air. Metal oxide, surface or subsurface mining. So there's all different ways that they can be extracted. You need to think about the reactivity series. Okay, know that stuff like potassium and sodium at the top, gold is really unreactive at the bottom. Then the big thing that you need to be able to talk about is the blast furnace. So there's 4 raw materials that go in: air, which is a source of oxygen, iron, or coke, which is a source of limestone, oh my god, is a source of carbon, and then limestone, which removes impurities. Okay, it's a lot hotter at the bottom than it is at the top. Slag, which is the impurities, then gets removed above the molten iron. Molten iron just means it's melted. Then there's a series of reactions. I wouldn't worry too much, okay, as long as you know a little bit about what's going on. So the carbon from the coke plus the oxygen react together to make carbon dioxide. That carbon dioxide reacts with more carbon to make carbon monoxide. That carbon monoxide then takes the oxygen from the iron to get iron on its own, okay? Limestone reacts with impurities to form slag, which floats on top of the molten iron. Okay, costs of extraction, obviously we need to transport it. There's energy cost. This is really hot, so we need to get the energy from somewhere, and also people to work there, labourers, stuff like that. The other then big kind of process you need to know about is electrolysis. Electrolysis is splitting of ionic compounds using electricity. What does oxidation and reduction mean? Reduction, oxygen is removed and electrons added. Oxidation, then oxygen is added and electrons are lost. Draw and explain how the extraction of lead into lead bromide works. Big thing for me, okay, is to remember panic. So positive anode, negative is cathode. So anode then is positive, it attracts something that's negative. Cathode then is negative, it attracts something that is positive. What is electroplating? Electroplating is used to coat a cheap metal with a more expensive one, such as copper or silver. The article to be electroplated is made the cathode, so the negative, because then the metals are positive and they'll be attracted to it. Okay, you also need a solution of their metals as well.